Informative path planning is a challenging problem in robotics that involves finding paths of high information gain while subject to budget constraints, with example use cases including wildfire monitoring or search and rescue. This problem remains to be solved in a manner that allows for widespread, real-world implementations, especially in high-dimensional spaces with non-trivial sensor constraints. In this work, we present a sampling-based approach that allows us to address these challenges. This is done by performing informed sampling in the high-dimensional continuous space and incorporating potential information gain along path edges in the reward estimation. This method rapidly generates a global path that maximizes information gain. We demonstrate our approach in an example use case of searching for multiple objects of interest in a large search space using a fixed-wing UAV with a forward-facing camera. We compare our algorithm to a sampling-based planner baseline and demonstrate how our method consistently outperforms the baseline by 18%.